So good afternoon, everyone. Today we have another second talk of ALG-AD project discussion, and today I'm happy to talk with Luc, who is from France, our French partner. So Luc will introduce himself and talk about his role in the project.
Yeah, so I'm Luc CHAUCHAT. I'm working for the CNRS in collaboration with UBO. I'm a research engineer. I'm working for the ALG-AD. My role in the ALG-AD project is to design the reactor, and I mean design the tube, design everything, and also the automation of the reactor. And now I'm working on I'm trying to improve the process, particularly the growth medium, in order to increase the ratio of digestate that we can use into the reactor.
Okay, Luc, can you talk us a little bit more in detail what kind of organism you are growing and what is the type of reactor you are using, please?
We are using Schizochytrium, Thraustochytrid strain, particularly Aurantiochytrium mangrovei.
Mm-hmm.
This strain is very interesting because it produces lots of DHA, astaxanthin, and of course some peptide and squalene also.
Wow.
These molecules are very useful for aquafeed.
Mm-hmm.
That's why we were interested by this strain.
And apparently the species is really fast growing species, isn't it? So you can get lots of biomass in really short period of time.
Yes, the growth rate is about 4 to 5 days per day. Mm-hmm.
Grams per liter per day.
Yeah.
Yeah. Okay.
So
okay. Yeah, it's quite impressive.
You can get a lot of biomass very quickly.
Mm-hmm. Okay.
This strain is only heterotrophic strain.
Right. Okay.
100% heterotrophic. So we don't need lights. Absolutely no lights.
Mm-hmm.
We can use light only to increase production of astaxanthin.
Okay. Okay.
We are working on this point because we don't know yet which wavelengths we should use in order to increase the astaxanthin content at the minimum cost.
All right. Okay.
Of course, we cannot use natural light. I mean, sunlight. We will use electric lights like LED.
Yeah. LED. Okay, but the main purpose of ALG-AD project, as probably people knows, but maybe not, is remediation of waste. Yeah, so basically the species was chosen for this purpose because of the fast growth and potential high rate of remediation of the digestate nutrients, isn't it?
Yes, and these strains can consume a lot of ammonium.
Right. Okay.
It is made of ammonium, so that's why we prefer to use this strain instead of chlorella or other species usually used.
Okay, yeah. Because like in other pilots, like we discussed with Claudio last week, so we're using Senedesmos and chlorella, but you have completely different approach with different species.
Yeah.
What is good because it's benefit the project results and outputs.
Actually, we use this strain instead of chlorella, for example, because of the DHA content.
Right. Okay.
Because only marine strain can produce such molecules like DHA, squalene. There is other strain, but these two molecules are very, very useful for feed.
Yeah.
And also for pigs and animals, but only marine strain can produce it. And Schizochytrium is known to be used for to produce such molecules.
Yeah. Okay, because like, so first purpose of project activity is to remediate waste from anaerobic digestion plants. But second point in our project is to produce biomass, algal biomass could be incorporated in the animal feed nutrition. And of course, biochemical composition of producing biomass is also really important. So I get your point. Thank you.
For our side, we think that we cannot divide it into two objectives, the two purposes.
No, of course not.
Exactly similar. At the same level. We cannot only to do a bioremediation, but bioremediation we will produce biomass, but for what?
Yeah.
And we cannot just produce Schizochytrium because it's already done by other big company like DSM or other huge company. We want to work on the two aspects of the project at the same time.
Yeah, no, it's really clever, and especially like whole project is based on the circular economy. Then we're using nutrients from the waste sources, producing valuable biomass for the future production of the valuable compounds for the animal feed. Okay, Luc, can you please explain us a little bit, because you're working with this specific strain of microalgae, and so your reactor was installed in industrial location. So this company, Cooperl, who is the big company involved in different activities, and one of the part of this activity is anaerobic digestion of, I think so. Can you please explain a little bit more, because you...
Cooperl is a big company in animal feed production, but also I'm looking for the English word. Sorry.
Yeah, it's okay.
Abattoir, I don't know how to say it in English.
Slaughter of
slaughter. Voilà. And it is their two main activities. And they built last year, and it's just starting now. It's just starting now. The big AD plant, one of the most important in Europe. They will produce about 150,000 cubic meters per year of digestate.
Okay.
Already, all the processes. They will filter it and produce ammonium and phosphorus. But the Cooperl was interested by the ALG-AD project because it could be another way to use the digestate, to valorize the digestate, to upscale to valorize the digestate.
The digestate, yeah, okay. Luc, thank you. I just would ask if people who is watching us and has any question, please put this in the comment box, and we will try to answer this on time of the live discussion. Otherwise, we will be contacting you in the comments and just give you feedback on the question what you asked. So, okay, and so basically this algal pilot was installed in Cooperl facilities, isn't it? Just in order to, first of all, remediate anaerobic digestion waste from the activities, and potentially to use this algal biomass in the feed nutrition trials. So can you talk a little bit more about what size of the plant was installed, and about the activities related to it?
Actually, Cooperl, before to build their huge AD plant, they built a small AD plant of only 20 cubic meters, which is only a small one, a pilot, and we use their pilot to produce a digestate for our own pilot. We don't use their big.
Right. Okay. Mm-hmm.
Of course, we are just close. It's we made a bioreactor of 2 cubic meters only, which is made of 9 cylinders of different size. It's made of PMA.
Mm-hmm.
We produce it's a bioreactor working like it's a plug flow reactor, and all is automatized.
Right. Okay. Mm-hmm.
It means that our purpose is that nobody will. We want to reduce the human cost.
Right.
To use
to minimize it, isn't it? Yeah.
So all is made to just inoculate the reactor and after it has to run by himself.
Okay. Okay.
So,
It's a really clever idea. Okay, so basically, it's still kind of pilot, isn't it? Because it's like will not remediate lots of digestate. As we know, then the rate is still quite low. We're working experimentally on it. But can you tell us then how the lockdown situation affects the cultivation of algae on site, and what is the
it's because of the lockdown. It's impossible for us to get to Lamballe because the train are blocked. Everything it's on the Cooperl asks us to doesn't come.
Right. Okay, so the clear instruction then it's put in place.
So we have to stop all. We will restart our experiment on the 15th of June.
Right. Okay. Mm-hmm.
And we hope to produce enough biomass till the end of July for the animal feed trials.
Right. Okay. Yeah. So this is kind of a little bit of pressure by the outputs of the project. Yeah, lots of pressure. Yeah, I know. And of course, we put in now this restriction time. Then we could not do anything, and basically need to be feeling.
And we are not. We have no power on it. It's impossible. Right. We just wait.
But basically, because of the growth rate is so high of this particular species, so what your kind of expectation if everything will work well? So how quickly you
actually it works well. It works well by batch, only by batch. Unfortunately, we cannot use our automation.
Right. Okay.
Not good enough. It doesn't work well enough to use the automation. We can only use the batch system.
Right. Okay.
We can reach 4 to 5 grams per liter.
Okay.
Not that bad, but we hope to increase the digestate ratio after July, after September even, and to improve the concentration. Our target is 20 grams per liter.
Right. Okay.
That we would like to reach.
Yeah.
But for that we have to improve the growth medium. It's very difficult to know the element lacking into the digestate to permit the growth culture of the growth our strain.
Yeah, because we're working with these waste nutrients, so it's really difficult sometimes. We measure main macronutrients and some of micronutrients available by simple analysis, but lots of other compounds still containing in digestate, then we can't even basically approach to understand.
Just for example, we have already noticed that selenium is lacking into the digestate, and we have to increase the selenium content into the digestate to allow a better concentration of the culture, the strain.
Right. Okay. But anyway, just this approach is quite innovative in terms of biomass productivity, because it's higher than the other species. Yeah.
Bibliography, according to the literature, Schizochytrium is not known to be used as a bioremediation strain.
Yeah, so this is innovation coming in.
The use of this strain is very innovative. On the bioreactor is innovative because it's only it's a big one, 2 cubic meter. It's not that bad, but it's not the biggest one in the ALG-AD project. But all is automatized.
Mm-hmm. Okay, and basically, so I'm just checking the question, and this is about, so I can't get the question fully, so then probably if Siva can write a bit more description on his question, then we can answer during our interview or just probably later on. So Luc, so what's the kind of future objective, future plans for the pilot? So basically you will work starting on 15th of June on producing biomass
Yeah, the first target is to produce enough biomass in non-arsenic condition, enough biomass for the animal feed trials. It's the first target.
Yes, okay.
Planning of the farming is very
important. Yeah, no pressure.
So it's our first target, but the second target, of course, is to increase the digestate ratio in order to get to obtain 20 grams per liter. It's our second target.
20 grams per liter of biomass.
Yeah.
Okay. Okay. But what the percentage of digestate at the moment is used, and what you plan to?
We only use 2.5% of digestate. Yeah. Sorry. We only use 2.5% of digestate, but we have already checked that we can use 80% to 100% digestate.
Wow. Yeah. So it's a big.
It means that digestate is not toxic.
Okay.
It's not toxic for the growth culture, for the growth of Schizochytrium. But there is many. The content of the digestate is not good enough. Not toxic. Below the huge growth rate. Right. It's difficult to obtain a good. There is many. The content of the digestate is not good enough. Below the huge growth rate. Right. It's difficult to obtain a good. There is many content of the digestate.
Sorry, it's just a bit of echo coming from the live. So some people join on only right now, and they ask where is this pilot installed. This is pilot installed in France, in Brittany. Working together, like we are working in ALG-AD project, academia and business partnership. So here we have CNRS and working with Cooperl, who's the company based also in Brittany for pig production and animal nutrition. So yeah, so this is the different system. It's another pilot installed under ALG-AD umbrella. And we're discussing with Luc about achievement and the future plans. Right, Luc, I think so my question has come to the end. Yeah, I was really happy to discuss with you. I think all other questions, if you will put in the comments box, we will happy to reply on it. And I just would like to say that next week, Monday, this roughly about this time, we will have another discussion with third pilot installed under ALG-AD in Ghent. So, Luc, thank you very much again, and so good luck for everything.
Yeah.
Yes. And we continue our hard work.
Yes.
Okay, thanks again.
Bye-bye.
Bye-bye.